Photometry technique used to represent population neuronal activity by recording fluorescence changes of neurons in specific brain regions, and is commonly used for calcium signal recording and neurotransmitter signal detection. Photometry can be recorded stably for long periods of time, so it is well suited for studying the correlation between animal behavior and neuronal activity. Today I introduce the R810 photometry system. The overall composition of the machine is as follows. First, connect the adapter and power supply of the machine and the computer. Then select the USB 3 cable to connect the USB 3 interface on the back of the machine to the USB 3 port of the computer. To prevent the computer's USB port is not enough, we can choose the USB hub included in the system. Now connect the USB hub to the power supply and the computer. Then select the USB 2 cable to connect the USB 2 port on the back of the machine to the hub. Then we connect the software key and the mouse. Now we connect the behavior camera included in the system and install it to the complementary bucket. The behavior camera has the option to be connected directly to the computer or to the USB hub. The camera support is flexible to adjust the height, angle, and so on. Small knobs on the camera can be used to adjust exposure and focus. The overall wiring connection is done. We connect the optic fiber to the interface on the front of the machine, then turn on the power switch. Now we're ready to experiment.
Open the software. The system will automatically test all the line connections. No connection problems. The software automatically enter the acquisition page. The software window is mainly divided into parameter settings on the left, real-time data in the middle, and video recording of the behavior on the right. First we set the experimental need for excitation light power. Directly through the software can be adjusted. The common power is between 20-50 microwatts. When the signal is weak, you can improve the power range. 410 nanometers light source can be used to respond to background noise. In addition to the normal recording mode, the sequential recording mode is mainly used for long-time experiments. Channel settings. First select the recording frame rate. The recommended parameters for 4120 fps. The most commonly used for 60 fps. And turn the exposure and gain adjustment to the maximum. You can see the optical fiber imaging clearly. You can adjust the focal through the focus ring on the front of the machine, so that the fiber imaging more clearly. Then adjust the channel ROI diameter. until the same size as the fiber. After the completion of the adjustment, must remember to adjust the gain to the minimum, or too high gain will reduce the signal-to-noise ratio. Save the parameters to enter the event marker settings page. First, the system can accept TTL signal input from external devices and present the TTL signal input as event marker in the signal acquisition window. We can select the corresponding channel and the color of the marker. Second, manual marking, directly naming the event name. You can also select the channel of the marker, custom marker color, marking hotkeys, etc. Third, the system can output TTL signal to trigger external devices. Through the software can choose the output conditions. You can choose to start recording on the output signal, or signal DF grow to a certain amplitude, and then output TTL signal. In addition to, we can also directly set the TTL signal pulse width, frequency, duration and other parameters. When these parameters are set, you can click Preview directly for pre-experiment testing. In preview mode, all parameters can be freely modified to achieve the best test results. After the preview, you can click the record to start recording. Manual marking can be done by keyboard hotkeys or by clicking on the icons directly under the software window. The presentation of the data can be selected from the original data, or by clicking Trace to change to Delta F display. Delta F calculation basis can be selected by the next F0. Of course, do not forget the behavior recording function. We can record video and animal tracks directly through here. The software based on color difference to determine the direct difference between the animal and the background. Change the recognition interval so that you can more accurately mark the experimental animals. We can import saved ROI areas directly, or add them directly through the tool. Each ROI area can be customized with a name, corresponding channel, and marking color. Because the software also adds event markers to the signal recording window when the animal enters the ROI area. Of course, when the animal enters the ROI area, you can also set the parameters of the output TTL signal so as to achieve the purpose of interfacing with more devices. When the experimental recording is completed, we need to analyze the recorded data. Click Analysis to enter the analysis page. We import a set of data about LHA brain regions and defense behavior. Video data and fluorescence data can be imported simultaneously. The software also supports importing videos recorded by other software in MP4 format. Firstly, the software will analyze the information about the data, such as the recorded frame rate, excitation light pattern, etc. Then you can choose to clip the data. Data clip can be modified by the coordinate range in the upper right corner and the length of time to be kept. Clicking on Save and Import will save the cropped data and video and re-import them to the analysis page. The data pre-processing can be done by selecting Baseline Correction, Smoothing, Motion Correction, and the change of data under different processing can be viewed by clicking Trace. And the processed data can be saved as CSV file separately. After data pre-processing, enter the Event Analysis module. You can select or add event markers according to the behavior video. Modify the event interval for event mapping. Directly generate heat maps and graphs, and all the images can be saved. After event analysis, the data can be saved as CSV files for the next step of intergroup analysis. For intergroup analysis, you need to import the trail data after event analysis and click on the plot to generate intergroup. Comparative fluorescence heat map and curve. The image-related axes, reference lines, and color intervals can be adjusted manually. And the delta F processing results and Z-score processing results can be saved in SVG format, which can be opened in other image processing software. In the animal trajectory analysis function, we directly import a set of trajectory data. And after importing the data, the software will automatically generate the trajectory heat map and trajectory map. The track heat map can choose different background colors. And the track map can import pictures as background. We can choose to show the ROI area. And the software will also calculate the duration of ROI area.
Fiber photometry experiments require accessories to transmit light, such as optical fibers and ceramic ferrules. These accessories need to maintain the same numerical aperture so that signal loss can be minimized. The black ferrule is more suitable for fiber photometry because the black color can avoid the interference of ambient light. Because most experiments are conducted in the natural light, as the software now sees this data. When the animal is free to move, the change of light will cause dynamic interference to the signal, and the black ceramic ferrules and black sleeve can be a good barrier to the interference of ambient light. In multi-channel experiments, we can choose multi-channel fiber to connect multiple animals on multiple brain regions. We recommend choosing ceramic ferrules with a smaller diameter for multiple brain regions experiment. Regarding the photo bleaching, because different brands and different materials of fiber have different autofluorescence, if not specific low autofluorescence fiber, Ordinary fiber needs to be bleached with a laser for 1.5 hours before being used for fiber photometry, which can reduce 75% of the fluorescence.